All right, today's lesson is on something called the Pythagorean identity. The Pythagorean identity is very similar to the Pythagorean theorem, and it comes from that. If you look at the unit circle, remember the unit circle has a radius of 1. I can label this as x and this is y, and by definition, if this is theta, sine is opposite over over hypotenuse, sorry. So the sine is your y, your cosine is your x. So x squared plus y squared equals 1 squared, or cosine squared plus sine squared equals 1. I just write it backwards. Sine squared plus cosine squared equals 1. Now, these are just variations of that same equation. If I subtract cosine squared from both sides, I get this one. If I subtract sine squared from both sides, I get this one. And I will use these for some of these examples because on this first one, find the cosine of theta. Well, if I don't know cosine of theta, but I do know sine, I'm going to use this one. I could always use sine squared plus cosine squared equals 1 and just solve for the missing term. Step number 1 is find the quadrant. What quadrant are we in? And that comes from this statement right here in the problem. Right? So the first problem is sine of theta. It's given that the sine of theta equals 2/3 and theta is between 0 and pi over 2. Find cosine. Right, I'm going to leave this over here so you can write those down. But what does that mean? Well, if you write this one time, we can figure out the quadrants very easily. This is 0 or 2 pi. Since these are in radians, I'm writing radians. This is pi over 2. It's just 90 degrees. This is pi, and this is 3 pi over 2. So this is quadrant 1 between 0 and pi over 2. This is quadrant 2 between pi over 2 and pi. This is quadrant 3 between pi and 3 pi over 2. And of course this is quadrant 4 between 3 pi over 2 and 2 pi. So this statement right here tells me that this is quadrant 1. Why is that important? Because I know that cosine, all seniors turn crazy, cosine is positive in 1 and 4. So if I'm looking for cosine and I know it's in quadrant 1, I know my answer is positive. Okay, so this is going to be a positive answer. Right, so I'm going to use this second formula here. So cosine squared of theta is equal to 1 minus sine squared of theta. But I know the sine squared, so I can take that and put it right there. So it would be 1 minus 2/3 squared. And 2/3 squared is 4/9. So I'm going to rewrite 1 as 9/9 so I can subtract them. And that would be 5/9. But that's cosine squared, so cosine would be the square root of that, which is plus or minus. But I know that my answer is going to be positive, so positive square root of 5 over 3. So knowing that the sine is 2/3 and it's in quadrant 1, my cosine is square root 5 over 3. All right, the next one, cosine of theta is negative 5 over 3, which right away tells me it's either in quadrant 2 or 3, because cosine is negative in 2 or 3. This one right here tells me it is between pi and 3 pi over 2. This one is quadrant 3. And the sine is negative in 3. So only the tangent's positive in 3. So because I'm looking for the sine, I'm going to write down sine squared of theta equals 1 minus cosine squared of theta. That's just this one right here. And if you need these, I can put these over here, but you should have just paused when I did them the first time. All right, so 1 minus negative 5/8 squared. Squaring that negative is going to give me a positive. I'm going to write this one first, 25 over 64. This is positive, but it'll still be a minus. And I'll rewrite 1 as 64 over 64. And if you have your calculator, you can see that's 39 over 64, but that's sine squared, so I take the square root of both sides, so sine of theta will be the square root of 39 over 8. Square root of 39 cannot be simplified, so that's it. Now if you'd like, you could try this one on your own, so you can push pause. I will go ahead and do it, and then just check your answer when you are done. I know this is in quadrant 4. And the cosine in quadrant 4 is positive because my x values are positive in quadrant 4. And cosine is just your x. So I'm looking for cosine, so this would be cosine squared of theta equals 1 minus sine squared of theta. So it'd be 1 minus negative 7/9 squared. But when I square that, it's going to be, this is going to be a positive, but minus that positive. So it'll be 49 over 81. And I'm just going to write the 1 as 81 over 81. And if you subtract those correctly, you get 32 over 81. Take the square root, and oops, I forgot to do something on this one. This should have been a negative. Okay, my answer should have been negative on 2. This one's positive, but the square root of 32 has a perfect square in it. It has a 16, and the square root of 16 is 4. Always, always, always simplify your radicals. So the cosine of, the cosine of theta is 4 times the square root of 2 over 9. And that's everything. Hopefully you understood this. A little shout out to my gelato gang and my light brigade. Have a wonderful day.